Hello everyone. From this tutorial video onward, I'd like to transition to fluid dynamics, or the study of fluids in motion and the forces involved. The most basic quantity to measure is the volume flow rate for fluids in motion, and as suggested by the title of the term, is simply how quickly an overall volume of liquid will flow through something. Mathematically, this is defined as Q equals volume divided by change in time. Although if we look at it from a geometric perspective, we can see that, provided the volume takes up the entire container it is flowing through, the volume equals the cross-sectional area of the container times the length or distance of it. So our formula now becomes Q equals A times D all over change in time. And we remember, by the definition of velocity equals change in displacement over change in time, we substitute this in, and our final answer is Q equals cross-sectional area times velocity. This means that a wider container will have a greater overall volume flowing through it, and the flow rate will be greater if the velocity is greater. A very interesting thing to note is that, by definition of a liquid having a constant volume, the total volume flow rate will have to be equal throughout its journey, or that, by definition of what we proved earlier, cross-sectional area times velocity at point 1 must be equal to cross-sectional area times velocity at point 2. So this means that if the cross-sectional area decreases at a point, the velocity must increase for the volume flow rate to be the same. This also works with gases too, provided they are highly pressurized, so that their density remains constant. For example, in aerosol cans. A demonstration of this can be seen if you blow with your lips wide open versus if you blow with your lips more closed. In the first example, you should have felt that the velocity of the airflow was a lot slower, and so not as forceful, than the velocity of the airflow in the second example. In the next tutorial video, I will explain the Bernoulli equation, which also explains mathematically why a fluid, either a gas or a liquid, moving at a high velocity, has a low pressure within its region. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.